guys, Henrik Scholder here with Mechanix Menace. Today I will show you the process I am using when I put a new tube in the chassis build, and I will use this one here as an example. Of course, the ends of the tube need to be shaped perfectly to match whatever it is attached to. In this case here it's a flat surface to attach to this lower tube, and up here it's a cylindrical notch to a round tube up here. I will show you later on. And when doing the notching, it's quite common to use a hole saw like this. You can use it in either a tubing notcher, or I have used it in my big old vertical mill. It's not a huge issue to get the notch correct on one end of the tube, but the big trick and what kind of complicates things is to orient the two ends to each other in this rotational dimension. That can get kind of tricky, and actually I came up with a method that has worked real well for me during a sleepless night. I don't know really how I came to think about it, but since I have made a full CAD model of the chassis, I am using the CAD model. So I take the CAD model and then I put a plane somewhere along the tube here, and then I know the orientation of the two ends to that plane, and then using the CAD model I design these two notch templates for either end, which I 3D print, and then I can use them to orient the tubing ends perfectly to each other. So you see these flat parts here, those are aligned to that plane that I talked about. Yeah, I'll show you in more detail how I do this. First I will go through it fairly briefly, and for those of you who are interested in going into really deep detail, I will have a longer explanation afterwards. So the tube we are talking about here is the left upper front part of my ginormous transmission tunnel, and it attaches to this round tube here, which is basically the cross member for the dash panel, I guess you would call it. And then down here it attaches to this tube, which is the left lower part of the front end of the transmission tunnel. So if we have a look from above, I guess maybe you can see. So yeah, this is the more normal round notch for this round tube here, and down here it's this flat notch. And like I said, I use my CAD model and I put a plane along the tube, and then I use that plane to create these wings, or what you would like to call them, on both ends of the tube. And then we have the notch shape itself. This is the lower one, and this is the top one. So this is how the top one is connected to the tube up there, and you can see the orientation of those, of the flat part there, or the wings. And this is the lower notching template, and again you see that flat part there. I then cut a piece of tubing a little bit longer than I need, and in this case I have painted the ends black in order to hopefully enable seeing the scribe lines I will make. That's not something I do in real life because I can see them quite well without it. So I take a piece of tubing, and then I put the two notching templates on each end. like this, and I push them against a perfectly flat surface, and then I make sure that the spacing between them is correct according to the dimension I have taken from the CAD model. And then I use a scribe to scribe along the edges of the notching templates. The templates have a good press fit, so if I'm careful, I don't unintentionally move them when doing the scribing. I saw now that the black ink went away. But maybe, yeah, I think you can roughly see the scribing outlines. And then I just take my trusty old angle grinder, grind away all the unnecessary material. In general, I make the tube a little bit longer than what it needs to be, and then I kind of fine tune it in the end. Because even though I am fairly careful with doing everything perfectly, of course, sometimes it doesn't match exactly to the CAD model, so could be off by a millimeter or so, maximum, I would say. Yep, that's about it. So this first example I showed you was fairly straightforward. This tube here, it's just a straight tube with two notched ends, but in the chassis I do have some pieces of tubing that are bent as well, like the transmission tunnel tubes. And in this case, not only do you get to, or do you need to have the tubing ends correctly notched and oriented to each other, of course you also need the bend to be correct. It needs to have the correct angle and the correct position. So this kind of complicates matters a little bit. Here you can see the end of the tube. It has like a V-shaped cutout for the backrest cross member here, and in the front end it actually attaches to two round tubes, so that end is also notched a little bit more. It's a bit more complicated. So for those of you interested in the entire process from CAD model to tube tacked in place on the chassis, I will go through all the steps. The first step here is to create a fixture that will be used to position the tube. And in this case, we have this sandwich panel on the side of the transmission tunnel. So the tube here is, this side needs to line up with the inside of the sandwich panel. And here you can see how it sits, and it's a bit complicated because it's flush with this tube on the outside, and then it's flush with the bottom tube on the inside. So the fixture itself is made from 22mm particle board, and as you can see here, I had to go to some lengths to accommodate the part of the fixture that holds these tubes in place. And as you can see, the tube I showed you from the garage, this upper transmission tunnel tube is already in place. And here on the inside, you can also see 3D printed spacers here, which are needed in order to get the correct position of this fixture. As I said, it's on one side it's flush with the inside of the tube, and on the other side it's flush with the outside of the tube. So I then go into my CAD model and take out some measurements for the tube, which is this one here, some angles and some height coordinates. And in order to create a transverse line at the correct length coordinate, which is shown here on my center line reference with all these steel rulers, I use my 3-plane laser, but since I have the chassis jig in the way, I need to do this in 2 steps. So first I mark a line on the floor, like here and here, and I do it also up on the walls on both sides of the garage. And then I use my 2-plane laser to create a line along these guide marks here. And then this line will actually be projected against the jig here. So this corner here is one end of the tube there. And yeah, this is one of the marks on the wall. So the next step is to mark out the height coordinate. The laser instruments I have, many people say, oh, it's a laser, it's perfectly accurate. Of course it's not. And I have checked both lasers for accuracy, and I have made this kind of reference guide or yeah, to check the accuracy. And as you can see, you have different accuracies. The vertical beam here is fairly accurate, and the horizontal beam in this direction is fairly accurate, but in this direction going outwards from the laser level, it's not so accurate. So that needs to be taken into account. And if I can place the laser perpendicular against the point I want to mark out and my height scale on the garage wall, I don't need to compensate for anything. But in this case, it's not possible to place the laser there. So I kind of need to accommodate this depth difference. So here I have measured how far away I am. It's like 2.1 meters, and this means that this beam rises 2.3 millimeters. So I need to take that into account when marking out the height coordinate. And then I can mark this horizontal line to mark out that height coordinate. Here I need to do it on the other side of the jig and then kind of mark it out on the edge and then project it to the correct side of the particle board. And this is my height coordinate scale on the wall here. Okay, so then using the angles from the CAD model, I can mark out the edge of the tube and this bottom cut on the fixture. So here is the line of the tube, and this is the angle of the cut for the bottom notch, so to speak. Okay, and now I can turn my attention to the tube itself. So this is what I showed you down in the garage. I first used the CAD model to design these 2 3D printed notching templates. And here you can also see the wings, and they are in line with each other against a plane here. You can't see it in the CAD model. Little close-up of this and from the inside, and here you can see that these 2 line up. They are parallel with each other. This is what it looks like with just the 2 templates. And here I have also taken the measurement between the 2 templates to get the correct length of the tube. And like I showed you in the garage, I basically put this on the tube and then mark out, scribe the lines, the end of the cutouts, and then cut them out. In reality, I made top notch first, and then I waited with the bottom one until a later stage. Here you have this top transmission tunnel tube and then the front one, and here I manually ground out these notches, because this tube that I'm working on, it needs to fit both here and then on this transverse tube below the dash that I showed you in the garage, and then of course the bottom end needs to be in the correct position. So basically there are 3 points along the tube that need to match. So I did this in minute steps. And here I check with a carpenter square that the tube is lining up with this line here on the jig, which it does. As you can see, I have to clamp it in several places and hold it in place up here with this tube underneath the dash. And then I make this last cut here, or the notch, on the lower part of the tube like this. So now I have come to the stage where I actually can start tacking it in place. So you have tacks here and here, and another view from the inside there. And this is what I ended up with. And this is what it would look like in the CAD model at the same stage. Another view of it tacked in place. And the funny thing was that after I had tacked it in place, I measured the horizontal distance here to the edge of the tube. I didn't remember what it should be in the CAD model, but I remembered, okay, 327 millimeters, which was an easy figure for me to remember because I had a Chevy Nova that had a 327 in it. So then I went up into the house and checked the CAD model, and yep, 327 millimeters. That was what it was meant to be. So it ended up perfect. So thank you for watching, and if you have any comments or if you have any questions, or maybe there is something you would like to see me explain in more detail in a video, yeah, please don't hesitate doing that. But I guess I will see you sometime in the future. Thank you.